So what we have here is another rational expression. 6 minus x in the numerator is a polynomial, and in the denominator we have x minus 6, which is also a polynomial. So one of the questions that we answered earlier was, where is this expression undefined? So if we have to find the values of x at which the rational expression is undefined, we set the denominator to 0. Solve for x. This tells us that when x is equal to 6, the denominator becomes 0, which means the expression is undefined at x equals 6. Now, in this question, what we are going to do is reduce the rational expression to the lowest terms. Now, what do we do when we reduce a fraction or a rational number to the lowest terms? First, we factor the expression in the numerator and the denominator, and then we cancel common factors. Factor the numerator and denominator, cancel common factors. The process is exactly the same, but here we have polynomials instead of numbers. So 6 minus x and x minus 6 differ only in sign. And what does that mean? So in the numerator, if I factor out a negative 1, so 6 is negative 1 times negative 6. Do you agree this is equal to 6? So if I factor out the negative 1, I'm left with a minus 6. And I factor out a negative 1 from x, negative x. So that's negative 1 times x equals negative x. So if I factor the negative 1 out, I'm left with an x, which is a positive x. Don't forget to put the positive sign over the whole thing is divided by x minus 6. So this is equal to negative 1 times, and we're going to switch these terms. I'm going to move positive x to the left, minus 6. So negative 6 plus x is the same as x minus 6. If you move a number, make sure you're moving the sign along with it. If I move the 6, the sign has to go with it. And that's how I get an x minus 6 over the denominator, which is also x minus 6. So what did we do first? We factored the expressions, and now we cancel common factors. So if you put 6 minus x over x minus 6 in the lowest terms, we get negative 1 by canceling common factors. So similarly, if you have 3 minus x over x minus 3, you have to recognize that they're almost the same except for a negative sign. So factor the negative out, and this is the negative of x plus 3. I'm sorry, x minus 3. Because negative times negative gives you a positive 3. So it's negative 1 times x minus 3. When you factor a negative 1 out, the positive changes to a negative, the negative changes to a positive. So that's divided by x minus 3. So it cancels out and you get minus 1. Something like this. Let me do just one more example. If you see an x minus 1 over 1 minus x, you can be sure it's a negative 1 because 1 is the negative of the other. If I go a minus b over b minus a, when the order gets switched with a negative in between, you just know that 1 is the negative of the other, and you get a negative 1. Now let's look at the next problem, which is, and the question, remember, what we're doing is reducing the given rational expressions to the lowest terms. So what's our first step? We factor the numerator and denominator. The next step is cancel common factors. So we're going to do that in the exact same order. So factor first. Now you have to recognize perfect squares. 25 is 5 squared, and what you have is 5 squared minus x squared. So this is a difference of squares. A squared minus b squared is a plus b times a minus b. If you see the expression as a difference of squares, then write it as a squared minus b squared, and that is 5 plus x times 5 minus x. So let's write this down. So we have 5 squared minus x squared over x plus 5, and that is equal to 5 plus x. That's a difference of squares, so that's 5 plus x times 5 minus x. The factoring of a difference of squares is easy because you just use the special product. And now we've factored the numerator, factored the denominator, so the first step is done. Our second step is cancel common factors. X plus 5 is the same as 5 plus x, so that gets cancelled. And this is equal to 5 minus x. That is what we have when we reduce it to the lowest terms. So we're going to reduce this rational expression to the lowest terms, which means the first thing is we factor the expression, which is a polynomial, in the numerator, and we factor the denominator completely. So again, do you recognize that it is a difference of squares because 49 is 7 squared? Just memorize all the squares. As soon as you see a square, you have to be able to recognize it. And then in the denominator, we have 7 minus x. So this is a difference of squares. This is the special product that helps us factor the expression. So it's the first term plus the second term without the squares. First term minus the second term without the squares. So it's x plus 7 times x minus 7 divided by 7 minus x. We're almost there because we have to now cancel common factors. Now I want you to notice, remember we did this repeatedly. There's an x minus 7, but this is a 7 minus x. Remember that one is the negative of the other. And what does that mean? If I go x plus 7 times x minus 7, I can write the denominator as the negative of x minus 7. It's the opposite sign. It's the same x minus 7 except that it's the opposite sign. And now we're ready to cancel common factors. And this is a very important thing to observe and remember. If I go x minus 4 and 4 minus x, you have to know that they differ only in sign. They're in opposite signs in the exact same expression. So these cancel and you get a negative 1. So x minus 7 over x minus 7 is a 1 with a negative in the denominator. So overall, when we combine all the terms, you get x plus 7, but the sign is going to be negative because of the negative sign in the denominator. Next, we have another rational expression. What we're going to do is factor the numerator because we want to reduce it to the lowest terms. Numerator cannot be factored any further because it's a linear expression. A quadratic in the denominator can be factored further. So the quadratic in the denominator is x squared minus x minus 6, and this is 1 times x squared minus 1 times x plus negative 6. So what we do is we multiply the extremes. One is negative, the other is positive 1. So that gives us negative 6. So we multiply the coefficients, the coefficient of x squared and the constant term to get a negative 6. Now we need to factor the negative 6. So one option is negative 3 times 2, and that works only because negative 3 times 2 is negative 6, and negative 3 plus 2, when you add the two factors, you get a negative 1. And that works because our middle term is negative 1 times x. And The two factors should add up to the middle term. So now what we do is we write x squared minus x minus 6 as x squared minus 3x plus 2x minus 6. So this is equal to x times, factor the x out, x minus 3 plus 2, factor the 2 out, and you get x minus 2. Because 2 times 3 is 6, you get a 2. I'm sorry, that should be a 3. 2 times 3 is 6, so you get a 3. Factor the 2 out and you get an x. Next, the common factor is x minus 3. And once we factor that out, we'll be left with x plus 2. So let's do that. Factor the x minus 3 out times, the blue terms are left over from each. When you factor the x minus 3 out, you're left with an x, plus factor the x minus 3 out and you're left with a plus 2. So this is x minus 3 times x plus 2. X minus 3 times x plus 2 is x squared minus x plus 6. So let's write that down. X squared minus x plus 6 is x minus 3 times x plus 2. Now all you have to do is cancel common factors. And you're left with 1 in the numerator and x minus 3 in the denominator. So when you reduce the given quadratic expression to the lowest terms by cancelling common factors, we get 1 over x minus 3. One last example. Here is another quadratic expression. Now, let's first think about, where is this expression undefined? Is there any number I can plug in which will make the denominator equal to 0? Is there any real number I can plug in to make the denominator equal to 0? So when I subtract 1 from both sides, I get x squared equals negative 1, and x then can be solved for by taking square roots on both sides. And you probably come across this before. Square root of negative 1 is an imaginary number. You cannot have a negative inside the radical expression. It gives you an imaginary number. It's not a real number, which basically tells us that you can plug in any real number for x and the denominator will never be 0. It is defined for all real numbers. So there is no real number for which it is undefined. Now let's quickly factor by grouping. Let's group these numbers and then factor it. The common factor for the first group, 2x squared plus 2, is 2. And that's 2 times x squared plus 1. The factor for the next two terms, take a negative out. X squared is a common factor because x cubed can be written as x squared times x to the 1. And obviously x is x times 1. So if you factor out the x in x cubed, you're left with x squared. Factor out the x in x and you're left with a plus 1. Since you factored out the negative, both the terms are positive, over x squared plus 1. So this is equal to, factor out x squared plus 1, and the leftover terms are 2 minus x squared over x squared plus 1. So cancel these two and you've simplified the expression and it's in the lowest terms.